Hello students, and here we are with the next session of physics, and our beloved sir KD sir will discuss all the 50 questions that you have already faced in today's NEET exam. And guys, I think you are ready to find the answers because जो भी हो चुका है बेटा, don't worry about that. अभी जो भी है मानना है, हम लोग को ये कैलकुलेट करना है क्या हम लोग जो भी आंसर किए सही है या गलत. So right now this is over to Mr. Kaustubh Das, who will explain all the answer, and we will be a little bit faster because we don't have much more time, because our chemistry will be also discussed after 1 hour. So this session will be from 9 to 10. So enjoy and find your answer and calculate your score, and don't forget to write us what is your score. Thank you so much. Over to Mr. Kaustubh sir.
Thank you, Dr. Kaur. And let us start discussing the physics paper today. I hope that everybody has done well. Though the paper was quite lengthy, I can understand whenever I was going through the paper at my home after you give the exam after 5 o'clock, whenever I've received the paper from your side. So I have checked that, yes, some questions was a little tricky, and in somewhere you have to spend more time. And I think the time management was one of the biggest factor in this NEET exam this time. So let us start discussing from the question number 1. The first question that you can see is given from the applications of the Biot-Savart's law. And here an infinite long straight conductor. This is the long straight conductor over here, as you can see, carrying a 5 ampere current. This is infinite conductor. So for that, if you want to find out the magnetic field at this point, you can apply the Biot-Savart's law, which is at a distance of 20 centimeter, and the value of the magnetic field P comes as mu0 I divided by 2 pi r. I hope that everybody can remember this value, mu0 I divided by 2 pi r. This is for the straight current carrying conductor. And if the moment you find out the value of B, you can understand the B is going to be perpendicularly outward directions if you apply the right hand thumb rule, the perpendicularly outward, and the direction of current is towards the positive x-axis direction. So the value of theta between the magnetic field and the value of direction of current or the movement of the charged particle, which is electron, it is at 90-degree angle. So from the Lorentz force expressions, we can now write down the force is going to be Q VV sine 90 degree. And by placing the values of B, that is mu0 I by 2 pi r, and the value of the velocity of the electron, which is given as 10 to the power 5 meter per second, and the value of mu naught by, you can adjust this formula to, if you want to reduce the time. So you can write it as mu0 by 4 pi into 2I divided by r. You can use that mu0 by 4 pi as 10 to the power minus 7. And if you do that calculations, the force, the value of the force that is going to come, which will be, according to our calculation, it is coming as 8 into 10 to the power minus 20 Newton. This is going to be the option number D. I hope that everybody has done this correctly. That was not a difficult question though. Now let us come to question number 2. In this question number 2, the dipole is placed in an electric field as shown. The dipole is placed in the electric field as shown. So here we have a positive charge basically, and here we have a diverging electric field. So, and along this direction, you know that along the direction of electric field, we have decrease in potential. So decrease in potential in the direction of electric field. So one thing you can understand, you can apply some common sense, you can negotiate with your options that the potential energy is going to decrease. So increase I can cross first of all. So I have to choose the options between 2 and 3. Now the force experienced by the dipole, because this is being positive and the positive charge is facing towards positive charge, so the dipole is going to experience the force along the positive x-axis direction. So the force is going to be towards the right and the potential energy will decrease. So here we come with option number 2 is the correct answer. Okay. Now let us go towards the question number 3. Let's see what we have in question number 3. Yes, it's an LCR circuit. It is an LCR circuit. Inductor L, capacitor C, and the resistor R are connected, and the potential across the L and potential across the C, potential across the R, it is given to you, and which are 40 volt, 10 volt and 10 volt respectively. The amplitude of the current flowing through the LCR series circuit is going to be 10√2. That is given as the value of I0, which is the peak value of the current, and across the L, that V0L, whenever we write down the peak value of the voltage across the inductor, it comes as I0 into the inductive reactance, which is XL, right? So from there, you can easily find out the value of XL. I'm not going to calculate, it will take some time for the calculations. I have already calculated. the value, and I'm going to tell you the final answer which comes actually. The value of XL by this way that I have calculated, as I can see here, which comes as 2√2 ohm. And similarly from the C, you can apply that V0C, which is going to be I naught into XC. So from there, you can find out the value of XC as well. And you can also find out the value of R from the formula V0R is equals to I naught into R. So you can have the value of R, you can have the value of XC, and you have the value of that XL. So now you can find out the inductive reactance, the impedance of the circuit, the total resistance actually, which is Z equals to root over of R square plus XL minus XC whole square. So if you get this formula, the value of Z as per our calculations, it comes as 5/√2 ohm. So your option number 2 is going to be the correct answer. I hope that some of you have marked it correctly. Though the question is pretty lengthy, you need a little bit time. If you are very much fast in calculations, you can do it within 1 minute time, or else it may take more than 1 minute time for the calculation purpose. Now let us come to question number 4. Let's see what we have in question number 4. We have the electromagnetic wave propagations in the x directions. Here the question is from the electromagnetic wave, which one of the following combination gives the correct possible directions of the electric and the magnetic field respectively. So electric field and magnetic field, for an electromagnetic wave are perpendicular to each other. So you have to choose the answer. It's very easy. It's not, I think these questions will not be requiring more than 30 seconds to answer if you think quickly, if you know the concepts. So here E is perpendicular to B. So naturally the E vector and the B vector dot product, if I take, is going to be the 0. So here, as we can see, in the option number 4, it is minus J plus K, and not option, yes, minus J plus K, and we have minus J plus K. Just 1 second. So here, which of the option is correct? As you can see here, minus J plus K and minus J minus K. So if I take the dot product, so minus minus become plus, and the plus K dot minus K become minus. So here in the option number 2 is going to be the correct answer. The E dot B vector is going to be 0, and option number 2 is the correct answer. Because in the other options, you can understand it is going to be plus 1, that is 2. It is going to be also minus 1, that is minus 2. And here it is minus minus plus, that is also plus, that is also plus 2. Here only we have the answer as 0. So option number 2 is the correct answer. Now come to question number 5. In the question number 5, we have a lens of large focal length and the large aperture is best suited as an objective of an astronomical telescope. Since which of the option is correct? Here the answer is not given in terms of focal length. The answer is given in terms of aperture. So obviously, whenever we have a objective is large aperture, so it allows a lot of amount of light to come in, and so that because the light is actually coming from infinite distance, so obviously the brightness of the luminosity of the light is going to get decreased unless you make the aperture is pretty high. So in that particular situations, large aperture contributes the quality of the visibility of image. That is also true. The large aperture, the large area of the objective ensures a better light gathering power. That is also true. Large aperture provides a better resolutions. That is also going to be true somewhere. So here all the answers are correct. So option number 4 is going to be your correct answer as per our views. Now come to question number 6. Here in the question number 6, if you start thinking from which of the options, you are going to waste your time. So you need to check which one for this match the following in this type of questions. You are think those parameters which are very much you are quite familiar of. So here the relaxation period of time, relaxation time, that it is going to be tau equals to you. I have already told you whenever we have discussed this in the class. So the drift velocity expression. The drift velocity expression is how much? What is the value of drift velocity? This is question number 6. Acha, if I go through the current density J, that J equals to, that expression J equals to comes as NEVD. So D goes to U, D goes to Q. Here D goes to Q we have in this option and in this option. So I can obviously cancel out these two options. Then after that, we have and then we have the electrical resistivity, and the value of the electrical resistivity, that is rho, which is, I have told you in the expressions, that is m by n squared tau. You can express this. So here, as per our conjecture, here the answer is going to be the option number 1. Okay, so option number 1 is the correct answer as per our conjecture. So now we are going to go towards electrical resistivity. We can, sorry, that's not what I'm now going towards the question number 7. In the question number 7, it is given as an electromagnetic wave of the wavelength lambda is incident on a photosynthetic surface of the negligible work function if the m is the mass of the photoelectron from the surface of the deep Broglie wavelength. The value of lambda d you have to find out. And so you know that the kinetic energy associated with the photoelectron is expressed as E equals to hc by lambda, where lambda is the wavelength of the photoelectron, and the lambda d, and we can also write down from the Heidegger Broglie hypothesis, which is going to be h by p, and that can be written as h by root over of, in terms of kinetic energy, we can write it as root over of 2me, right? And the value of E we can replace over here the expression of h by root over of 2m into, that is going to be hc divided by lambda, and we can get our answer. And here this is the value of lambda d. If you just solve for lambda, and if you solve for lambda and if you find out the value of lambda, you will see the answer is going to be your option number 3. The option number 3 is going to be the correct answer, 2mc by h into lambda d square. Now let us come to question number 8. Here in the question number 8, we have a particle released from the height of s and to the surface of the earth at a certain height. Kinetic energy is 3 times the potential energy. The height from which the surface of the earth, the speed of the particle at that instant. You have to find out the height, and also you have to calculate the speed of the particle at that instant. Okay, so we can definitely apply the conservation of energy here. Here it is given. I can whenever the particle is being dropped from the height s, so I can write down the potential energy over there and the kinetic energy over there. It is going to be your total, the mgs. This is the total potential energy stored over there, mgs. Now, as it is given, the kinetic energy is 3 times. The kinetic energy is 3 times the potential energy. So you can now apply this. You can put the value of this kinetic energy over here in this expression, and you can get the value of potential energy as mg into s divided by 4. And so kinetic energy, you can get this answer as 3 by 4 into mg into s, right? So this is going to be the potential energy and kinetic energy. Now, if you have to find out the value of the potential energy at that particular height concerned, you can write down mgh. This is our desired height, which you are going to calculate, and that is going to be your mgs divided by 4. And so from there, the value of h you can get as h divided by 4, which we have in option number 1, 2, and 4. So we definitely have to calculate the value of the velocity as well by placing that half mv square kinetic energy, which we have as 3 by 4 am into g into s. So if you get the value of v from there, you're going to get root over of 3gs divided by 2, which comes as option number 4. Don't if you are in hurry, you may give the answer in s by 4 and root over of 3gs by 2, but you have to watch carefully that 2 and 4 is a little different in the aspect of root over of 3gs by 2. It is under root of total root over of 3gs divided by 2. So you have to carefully mark this answer, because in the examinations you have so many things in your mind, and in hurry we always do this type of mistake even if we know the answer. Now let us come to question number 9. I'm going towards the question number 9 as per our calculations. Let's see what we have as the answer. It's pretty simple. I don't think it's going to be requiring so much of time. It's given 52 divisions, circular scale divisions, and here 1 millimeter corresponds to 100 divisions. So here you can find out the least count, which is going to be 1 divided by 100, which is 0.01 millimeter, and gives us the value of 0.001 centimeter. So finally, if you multiply with the 52 into 0.001 centimeter, you get the total, the reading of the scale, which is going to be 0.052 centimeter. Here we have the option number 4 as the correct answer. Let us come to question number 10. Here in the question number 10, a thick current carrying cable. So you know it's a kind of cylinder we can consider. This is a thick solid cylinder. So in case of solid cylinder, in case of hollow solid sphere, how you know the potential, the value of magnetic field changes with respect to, if I consider from the center as we go outward. You know, in the surface we have the maximum value, and at the center it is going to be 0. And as we go towards the surface, the value of the P is also going to get increased. And as we go out of the cylinder, the value of V is going to get decreased. So here you can see in the option number 3, we have this type of graph from up to, this is the point where R equals to capital R. This is the radius where the value of the maximum magnetic field we get. And after that, the value of the magnetic field is inversely proportional. Come to question number 11. In question number 11, we have 2 charged spherical conductors of radius R1 and the R2 are conducted by a wire. Then the ratio of the charge, surface charge densities in the sphere, that is sigma 1 by sigma 2, you have to calculate. And you know that whenever we have connections between them in these 2 spheres, we have 2 spheres, for example, and the 2 spheres are connected, their potential is going to be, you know, the same. So whenever their potential is going to be same, I know the formula of the potential for the sphere, which is KQ1 by R1, which is equals to KQ2 divided by R2. And from there, if you find out the value of Q1 by Q2, it is going to be, you know, R1 divided by R2. And the value of Q is actually, you know, the surface area multiplied by the surface charge density, which is going to be 4 pi R square into sigma. If you put the values, I'm not going to find out the total calculations. We have already calculated after we get the paper from your side. So if you find out, if you put the values of 4 pi R1 square sigma 1 divided by 4 pi R2 square divided by sigma 2, so you have to find out the ratio of sigma 1 by sigma 2, which comes as actually, if you calculate, you'll see the value will come as R2 divided by R1. So here if we come with option number 2 is the correct answer. Now let us come towards question number 12. In question number 12, we have the number of photons per second on an average emitted by the source of monochromatic light of wavelength 600 nanometer when it delivers the powers of 3.3 into 10 to the power minus 3 watt, and the value of Planck constant is given to you. And if you have to place the value of Planck constant, if you have to multiply with the speed of light 3 into 10 to the power 8 meter per second, and then you have to convert the value of this nanometer, 600 nanometer to meter, is going to be taking a long time. And I hope that everybody has calculated the energy of the 1 photon by the formula of hc by lambda. This is going to be the energy of 1 photon, and you know, the power is given, the total power, and per second. So this is going to be 3.3 into 10 to the power minus 3 joule. That is the total energy delivered whenever you know, power delivered is given. So my answer of the number of photons is going to be the total energy, which is 3.3 into 10 to the power minus 3 divided by the energy of 1 photon that we have to calculate from hc by lambda. Lambda is given as 600 nanometers, which is 600 into 10 to the power minus 9 meter. And if you calculate, it may take some time for calculations if you do not know the direct formula. And it will be the answer that we have found out as 10 to the power 16 will be the number of photons. I hope this answer is 10 to the power 16 whenever you're going to get the answer key from the NTA. So I hope this answer is the correct. Number 13, come to the number 13 number of questions. In question number 13, let's see what we have. Answer. Here I have skipped the question number 13 to be solved at home. This is from, you know, that is pretty easy questions. I have not found out the answer. I need to verify the answer actually. I don't know how to have skip these questions. We have done this question several times, and I have told you repeatedly in the class that Newton's law of cooling is going to be coming in the examinations from the thermal properties of matter. So here it is cooling from 90 degrees Celsius to 80 degrees Celsius, and the room temperature is given as 20 degrees Celsius. And similarly, to cool it from the 80 degrees Celsius to 60 degrees Celsius at the same temperature, what is the time, you know, required. So this application has come from the Newton's law of cooling. I hope that everybody has done it. Here I am not finding out this answer right now because I have skipped out the question somehow. I have not calculated the value actually. So I'll definitely let you know in the Telegram group. after this class ends. Okay, now come to question number 14. The equivalent capacitance of the combinations shown in the figure. So here you can understand in these 2 points the potential is going to be constant. So this capacitor is not going to play any role. So here we have these 2 capacitors which are connected in parallel combinations. So the answer is going to be 2C. Only this capacitor and this capacitors will be effective. So the answer is going to be 2C. Now come to question number 19. The half-life of the radioactive nuclide is 100 hours. The fraction of the original activity that will remain after 150 hours would be how much? So here the half-life T half, which is given as 100, and the value of time after which you have to find out the fraction, which is given as 150. And so if I calculate, this is question number. Sorry, I have gone through question number 19 directly. Okay, let me solve, no problem. I have just skipped that part and have directly come to question number 19. So here, if you calculate T divided by T half, so you are going to get 150 divided by 100, which comes as 3 by 2. And you know the formula of the total, the fractions after the time T, which is going to be N0 divided by 2 whole to the power T divided by T half. So T by T half, we have got the value of 3 by 2. So I'm getting that N0 divided by 2 to the power 3 by 2. So N equals to N0 to the power 3 by 2. 2 to the power 3 by 2 means this is going to be 1 by 2 root 2. So the fraction N by N0, the value comes as 1 by 2 root 2. This is our answer of question number 18. This is the question from the radioactivity. Okay, half-life related questions. And so let me get back to the previous problem once again, because I have skipped these problems. Let us come to question number 15. In 15, we have the effective resistance. This is pretty easy questions. I hope everybody has done it properly. We have 4 resistors, each of given the resistance as 0.25, and whenever they are connected in parallel. So in parallel connections, R effective is going to be your R divided by 4, and which is given as 0.25, which is 25 divided by 100. So from there, if you can find out the value of R, which comes as 1 ohm, and from there, this is the 1 ohm, and if you connect them in series now, so in series, whenever you're connecting all of them together, we are going to get 4 ohm as an answer. So option number 4 is the correct answer, 4 ohm. Come to question number 16 related to prism. To find the value of the angle of emergence from the prism, the refractive index of the glass is given as √3. So here you can apply the Snell's law of refractions, and obviously you can get the answer. Here you can understand the incident angle as 0. So here, if I apply the Snell's law even, the value of R is also going to be 0 degree. So the light eventually actually comes straight. The light actually comes straight and falls on this surface, and whenever it falls on this surface, it is going to refract again. If I draw the normal in the surface for the refraction, the light is going to go away, away from the normal. So it is my finally the emergent angle. This value actually you have to find out, and the value of R is even 0. This is 60 degrees. So by geometry, we can get this angle as 60 degrees. So this angle is actually 30 degrees. So if I apply the Snell's law, so it's going to do 3 sine of 30 degrees, which is going to be the air. This is 1, so 1 into sine of E. So from there, the value of emergent angle, if you calculate √3 into how much it is coming, this is 60 degrees. Finally, √3 by 2, which comes as 60 degrees. So here the answer is going to be 60 degrees. Because it is going to be half √3 by 2 equals to sine E. So E is equal to sine inverse √3 by 2, which comes as 60 degrees. Come to question number 17. A small block slides down on a smooth inclined plane starting from the rest at time t equals to 0. And here, if you have to find out the displacement for Sn and Sn plus 1, it's a lengthy calculations. I believe that here it will take some time. And if you find out the value of Sn, the value will come as we have that we have calculated, which will come as 2a by 2 into 2n minus 1. And the value of Sn plus 1, if you calculate, it is going to be a by 2 into 2n plus 1. So if you take the ratio of Sn and Sn plus 1, the nth formula, it is going to be 2n minus 1 divided by 2n plus 1. So here we go with option number 2 as our correct answer. And then we are coming towards the question number, so escape velocity. here I think we have not found the answer somehow. The escape velocity from the Earth surface is v. You know the value of escape velocity we write down as root over of 2gm divided by r. This is the value of escape velocity. So another planet, the escape velocity from the surface of another planet having the same radius 4 times at the another planet having a radius 4 times that of Earth and having the same mass density. If you have to find out that one, same mass density. So if you find out this value, it should come as 2v. The answer should come as 2v. You can get the answer. I'm not calculating you. If you have to place the mass, you cannot take this mass. You have to convert that mass as density. So you know that density of the sphere is written as mass divided by volume. The mass divided by volume, which comes actually as m divided by volume is 4/3 by r cube. So if you can place the value over there, and you can get the answer. So let me calculate. Let's see how much we are getting after the overall calculations. So here v equals to root over of 2g instead of the m we are going to place is as d into 4/3 by r cube divided by r. So finally we get this v is proportional to root over of r square. So as you have the radius, it is becoming 4 times. Achha, sorry, it was my mistake. I have not calculated fully. That is why I sometimes record the calculations also. So it is becoming 4 times. Initially, it is proportional to r square, and whenever it is becoming 4 times, so it is going to be root over of 4r whole square, which is going to be root over of 16 r square, and finally we get it as how much we are getting the value. This is proportional to r 4 times. It is going to be 4 times actually. So here the answer will be option number 4 as the correct answer. So here 4 times is going to be your answer, not 2 times. So come to question number 3. This is also again the match the following. I hope everybody has done it. This is not a difficult questions again. The match the following was pretty easy. I have gone through all the questions and I have found out. The root mean square velocity, first of all, A goes to Q. Let's see A goes to Q. So A goes to Q are in my option number 2 and 3. And then find out anything like the pressure exerted by the gas. This is 1/3 mn this v bar square. So here we have B goes to P. B goes to P. So here we have already the answer. So B goes to P. First two, sorry, not mine. B goes to P. So here you can see B goes to P, but this is not the correct answer. So option number 3 is my right answer. Now come to question number 24. A spring is stretched by the 5 times and the force is given as 10 Newton. The time period for the oscillations when the mass is 2 kg is suspended by it is how much? Here it's pretty simple. You have to find out the force as kx, and from there the value of k you can find out, and the value of k that we have found out in our expression, which comes as 200 Newton per meter. If you put the value of force as and the centimeter, this has to be converted into meter whenever you're calculating the value of k in 200 Newton per meter. And the moment you get the value of k, the time period is expressed as 2 pi root over of m divided by k. And if you put those values, like mass is given as 2 kg, it is given as 200, and we are getting the answer as 2 pi divided by 10, and which is approximately is equal to 0.628. So here we go with option number 4 as our correct answer. Now come to question number 25. The velocity of a small ball. What is the time? The velocity of the small ball of mass m and the density d when dropped from a container filled with the glycerin. So it is questions from the Archimedes principle and the force of buoyancy. And the glycerin density is also given to you, which is d by 2. And the calculation, how we calculate the viscous force. That the upward force which is acting, the viscous force which is acting, this force, this is actually equals to the weight which is acting in the downward directions minus the force of buoyancy. So here weight I can write down, this is v into d into g, mass into gravitational acceleration. Mass can be written as volume into density, minus it is going to be the same volume, because whenever you are immersing that object, same equal amount of liquid is also being displaced from the Archimedes principle. We know that. So it is v, and then the density of the glycerin is going to be d by 2, and this is g. So if you calculate, it is going to be your v dg divided by 2, and if you place the value of v in terms of mass and density, it is again going to be m divided by d into d into g divided by 2. So dd gets cancelled out, and finally we get the answer as mg divided by 2. So here we go with the option number 1 as our correct answer for this question number 25. It may be different for your sets, obviously. Come to question number 26. A body is executing simple harmonic motions with a frequency of n. The frequency of its potential energy is going to be how much? You have done these calculations. You know the expression of potential energy is expressed as half m omega square a square, half kx square, and the total energy is expressed as half m omega square square. So here, if the frequency of the simple harmonic motion is n, the potential energy's frequency is going to be here 2n. So here we go with the option number 2. So answer is going to be 2n. Now let us come to question number 27. The nucleus with a mass number of 240 breaks into 2 fragments, each of mass of 120, and it is given that the unfragmented nuclei is having a binding energy of 7.6, and while that of fragments is given as 8.5. So the total gain in the binding energy in this process. The total gain in the binding energy. If you subtract, you are going to get the change in the binding energy. The delta E you can find out by the change in the binding energy. The change in the binding energy is 8.5. The value you have to just subtract 8.5 minus 7.6, which is going to be 0.9. And if you gladly mark in the option number 1, I think it is going to be the wrong answer, because it is the change in binding energy, and you have to multiply this value with the total number of nucleons, which was 240. So if you might multiply with the 240, the answer comes as 216 megaelectron volt. So here we have the answer as 216. That is option number 4 is our correct answer. Come to question number 28. Here we have the parallel plate capacitor. I have told you repeatedly in the golden hour class, even in our class, whenever we have discussed the same questions, we have shown you and have told you this you have to remember the magnetic energy density and the electrical energy density stored in the capacitor. And the value energy density, we know that comes as, if you gladly mark in option number 1, it's going to be the wrong answer somehow, because energy density is something whenever this is the energy divided by the volume, that is A into D. That we get at half into epsilon naught E square. But whenever you want to only find out the energy, it is half epsilon naught into E square multiplied with A and D. So here, as I can see, option number 3 is our correct answer. The energy you have to calculate, not the energy density you have to calculate. If it is the energy density, then option number 1 would have the correct answer. But here, option number 3 will be the total energy. Now let us come to question number 29. The polar molecules are the molecules are having the permanent. You know that it is a very much informative based questions, having a permanent electric dipole moment. The polar molecules are having the permanent electric dipole moments. Come to question number 30. It's pretty simple. You don't have to think more. You don't have to go all the steps. You can understand in 1 or 2 steps only. It is Z to Z minus 1. So here, if an electron, if a beta particle you have emitted, it should have Z plus 1. As it is now instead of beta, it is a beta minus. So it the atomic number is reduces by minus 1. So obviously here option number 4 is the correct answer. You don't have to go for other steps. You can only think about the answer in your first sort. So here option number 4 is the correct answer for question number 30. If it is a beta particle, then it would have Z plus 1 actually, because the atomic number increases by the factor of 1 whenever a beta particle emits when an electron is actually emitted, and the mass number is reduces by 4 whenever an helium is emitted from that. Now come to question number 31. In the 31, consider the following statements A and B and identify the correct answer. Here we have Zener diode is connected in the reverse bias when used as a voltage regulator. Yes, obviously it is true. We have the applications of Zener diode as our voltage regulator. So this is a correct statement. The potential barrier of the PN junction lies between 0.1 to 0.3. It is wrong, not the correct statement, because for the silicon it is 0.3 and for germanium it is going to be 0.7. So it is ranging from 0.3 volt to 0.7 volt. So this answer is going to be option B is incorrect. So here assertion, not assertion actually, the option A is correct and option B is incorrect. So statement 1 is correct and statement B is incorrect, which comes as option number 3 as our correct answer as per our guess. Come to question number, we have already 31 we have discussed. Now come to question number 32. Let's see in 32 what is our correct answer. And this is a little tricky, and the questions not tricky in fact, even if you know the expressions of displacement current. I have told you in the class already that if the question comes from the electromagnetic wave, you are going to get definitely a questions from the displacement current, which is expressed as epsilon naught d phi e divided by dt. I'm showing you the steps. It may be requiring for you also to understand this answer. So epsilon naught d phi e by dt, and the value of V is given. So I have to somehow express the electric field in terms of V. Well, I can write down this is epsilon naught, this is d by dt, and you know the phi is expressed at E into A. The electric field multiplied by the area of cross section. Area of cross section being constant, I can take it out of the differentiation. So it is going to be epsilon naught A, and it is dE divided by dt. But I cannot still find out my answer because I have as my E as my function of time, but I have to express this E in terms of D. So it is epsilon naught A. Again, we have to write down, they have to modify this E as D divided by D. D being constant can be taken out. So epsilon naught A divided by D, and we have dV by dt. Now you can differentiate this expression. We have V as V0 sine omega t. We can now differentiate this expression. This was a little tricky. If you have forgotten the formula of the displacement current, it will be quite difficult to give this answer. So like epsilon naught A by D, it automatically becomes C, the capacitance for the parallel capacitor. So it is C, and if I differentiate, it is going to be the sine function. It is going to be V0 into omega cos omega t. So if C V0 omega cos omega t, which comes in option number 1 as our correct answer. So here option number 1, ID equals to V0 omega C cos omega t is going to be your correct answer. Yes, question number 32 is over. Let us come to question number 33. This type of question we have done several times, dimension related questions. It is E and G respectively denoted the energy and the gravitational constant. So like total energy, how we express in gravitation chapter, this is Gmm by R, Gm1 into m2 divided by R. If you individually find out the energy and gravitational constant dimension, you are simply going to waste your time. Obviously, this question is really tricky. If you write down E's dimension, if you write down G's dimension separately, and you know for the dimension of G, if you cannot remember the value, again you have to find out the value of dimension of G, and then if you want to find out, it is going to be a wastage of time for you. So you know the formula of E equals to Gm1 m2 by R. So from there you can directly find out E by G, which is m1 multiplied by m2 divided by R. Now this is mass square divided by length. So m square L, L minus 1 actually. So we have here we have the option number 1 as my correct answer. This type of thing you have to understand question. You have to take the mindset in the NEET exam. Actually, there are a lot of questions and the time is very short. So question may be a little tricky, but it is not going somewhere it may be lengthy also, because this is the area that you know the NTA can set the paper as hard in physics especially. And whenever everybody comes from the examination hall, they everybody discuss that was tough, this was tough, that physics is tough, that is tough. But somewhere the question is tricky if you go conceptually. I think it's not going to take that much of time to solve. Come to question number 32, but yes, I still understand it is very easy to say. Sitting at my home, I'm getting time to solve these questions after your paper. And whenever you have in the examination hall, you have a different type of mindset. You have a lot of things to do, a lot of formalities you have to do within the same time, like signing and pressing the thumb impressions. So you know it little creates the disturbance at that moment, and obviously you are getting confused. All the formulas in the brain, you know, they do not. They actually go off. We cannot think in that proper dimensions. Yes, and in that frame, it is, if it is happening with you, it is happening with everyone. You don't have to worry about that one. You don't have to at all worry about if it is difficult for you. If you are not simultaneous, the condition is same for everybody. The condition, everybody is giving the exam. So if accordingly the cutoff will be set up. If it is difficult for you, it is difficult for the rest of 5 of the students as well. So accordingly, it will be set up. So you don't have to worry about. Give your full potential, that's all. And don't think that I have done this mistake, I have done this mistake. Not at all. You have done the mistakes, maybe others are also doing the mistakes at the same time. Come to question number 34. A convex lens A of the focal length 20 centimeter and a concave lens B of the focal length 5 centimeter. If you draw the diagram, the answer is going to become pretty quickly. And unless you draw it, if you go formula wise as the separation between the two lens as, you know, 1 by f1 plus 1 by f2 minus t divided by f1 plus f2, it is going to take some time if you want to calculate in this way. But if you start just draw this diagram, it is going to be pretty much easy for you to think of. Here is the convex lens and we have the concave lens. The separation between these two lenses is given as 20 centimeter, I hope. Yes, 20 centimeter. And yes, if a parallel light, suppose the light is now coming like this, and the focal length is given, convex length of the focal length 20 centimeters, sorry. Concave length of focal length 5 centimeter kept along the same axis at the distance of d. Sorry, my mistake. The distance was given as d. You are supposed to actually find out the value of this d. So if the focal length is 20 centimeters, so it's the light. If the concave lens was not present, the light should have made at a distance of 20 centimeter from the lens. So basically, this distance is going to be the 20 centimeter. And as the concave lens is now present, so the light is going to get diverged whenever they are going to come like that. Diverge means whenever the light will fall in the surface of the concave lens, it is going to be go parallel again. So basically, this distance is actually, the focal length of your concave lens, which is 5 centimeter. So if you want to get the distance between the two lens, you can subtract the 20 minus 5, and you can get the answer as 15 centimeter, which is our correct answer. Option number 2 will be the correct answer for this case. So come to question number 35. Here I have already calculated the value, and you know the process. This type of question you have done several times in your exam paper. In your mock test paper, you have done several times these questions. And fundamental quantity is the dimension of energy. So whenever we are getting this question, we have to write down energy, and that is equals to force to the power alpha, then acceleration to the power, acceleration to the power beta, and this time to the power gamma, whatever. And you need to calculate the value of alpha, beta, and gamma, and from there you can find out the value of E in terms of F, A, and T. Sorry, this is capital A. And if you get this answer, if you solve it, the answer that we have found out, I'm not calculating, you can put the value of energy's dimension in terms of MLT, you can put the value of force, you can put the value of acceleration, time, and you can get the, by comparing both sides, you can get the value of alpha, beta, and gamma. And here we have the answer as F, A, T to the power 2, which comes in the option number 2 as our correct answer. F, A, T to the power 2. Now let us come to the section B. We have discussed already 35 questions within this 46 minutes timing. Now we have here a step down transformer. In the question number 36, we have a step down transformer, and the AC mains supply is given 220 volt, operate at an 11 volt, power is given 44 watt. Ignoring the power losses in the transformer, the primary current, you have to find out the value of IP. You have to calculate. The section B question that I have gone through, and the question was not difficult, but the question was a little lengthy. You may have to calculate. You have to do some steps to get your final answer. So here, the transformation ratio, how we write down the transformer ratio, that is written as NS by NP, and you know that NS by NP secondary, S goes for secondary, P goes for primary, which is VS divided by VP. The value of VS, secondary output, secondary voltage is given at 11, so it is 11. Input voltage, which is given at 220, so it is 220. So we get 1 by 20, the value of VS by VP. And now we can get the answer as IP, which is going to be VS divided by VP multiplied your secondary current, which is that we have to calculate. It is not given directly to you. The output power is given as 44 watts. So you can know the power equals to current multiplied by voltage. So it is 44, which is IS multiplied by VS. So the value of VS is 11. So from there, the value of IS we can get as 4. So it is going to be 1 by 20 multiplied by 4, which is 1 by 5. That gives us the value as 0.2. So here we go with the options 1, that is 0.2 ampere, which is going to be our correct. That is going to be our answer. Let us come to question number 37. After that, the ball of mass 0.15 kg is dropped from a height of 10 meters, strikes the ground and the rebounds to the same height. Then the magnitude of the impulse imparted by the ball, as it is returning back to the same height, that you have to understand. So whenever the ball is falling down, just before it touches the ground, the velocity, whatever velocity that we get, And when it is going to the same height, the velocity, final velocity again it is 0. So whenever it is rebouncing back, we have the same amount of velocity. So the change in momentum, we can take the value as 0. So it is going to be 0 kg per meter second. Come to question number 38. A particle moving in a circle of radius r with a uniform speed takes a time t to complete the revolutions. It's pretty not lengthy. In fact, if you know the formulas and you do step by step, you're going to get your answer. Question seems to be difficult, but seeing the options actually, the options are horrible to see, but it is not in fact difficult. So v equals to, for the circular motion, 2 pi r divided by t, and you need this value of v in the expressions of projectile. Now, whenever we express the value of maximum height, h max, which gives us the value of u square, sine square theta divided by 2g, which is given as 4r. So from that value, you can get the value of sine theta, putting the value of v as 2 pi r by t. As per our calculations, we have already calculated the value of sine square theta that we have found out, which is sine square theta from this expression. Putting the value of v over there, we have this value 2gt square divided by pi square r. So naturally, the theta from there you can get this is sine inverse 2gt square divided by pi square r whole to the power half. This is our answer as per our conjecture. Now come to question number 39. In question number 39, a particle of mass m is projected with a velocity of v, which is given as k into ve, where ve is the escape velocity and given as k less than 1. So naturally, the particle has been projected, which is less than the escape velocity from the surface of the Earth. The maximum height the particle can reach is how much? That is what you have to calculate. So naturally, you can apply whenever you have thrown the particle, then there is no potential energy, and whenever it has gone through a height, the potential energy is there. Whenever it has reached to the maximum height, suppose the maximum height is h. So I can apply the conservation of energy over there, and I can write that half m v squared, which is the potential energy expression. That is g into m divided by r plus h. So by calculating putting the value of ve as m in k into ve. Sorry, this is v square, not ve square. I've done by mistake. This is v square, and you can put the value of v as k into ve, and from there, if you find out, I'm not calculating fully, that I have done in my calculations that I can see here, that calculation has come k square divided by r, which is h divided by r into r plus h. So from that value, you can find out the value of h, which comes as r into k square divided by 1 minus k square. This is going to be your value of h. So here we have r k square divided by 1 minus k square, which is coming with option number 4 as our correct answer. This is question number 39. Let us come to question number 40. Here we have a car starts from the rest accelerating at 5 meters per second square. Here also, I was going through the calculations, but I have not found out after all the result that is going to be found out. Here these questions, here we have an acceleration in the downward direction, which is g whenever the ball is being dropped. I'll inform this answer in the Telegram group, because finally at the last moment I have not solved the full answer. Definitely make you know the answer, what exactly correct answer it will be for this question number 40. Like g is acting downward, and whenever the ball is being dropped, so in the initial moment, the acceleration, we have a pseudo accelerations which is acting in the ball as well, which is in the opposite direction. So here you need to find out the value of net accelerations, the value of pseudo acceleration, which is 5 meters per second square. Taking this concept, you have to actually find out this answer, but I have not finally calculated which of the option is correct. I'll definitely let you know this question number 40 in the Telegram group. Come to question number 41. A point object is placed here at 60 centimeter from the convex lens of focal length 30 centimeter. Okay. If a plane mirror were put perpendicularly to the principal axis of the lens and at a distance of 40 centimeter from it, the final image would be formed at a distance of what? So here you can simply apply the formula. You don't have to put any effort. If you can find out the final image formula using the lens formula, and the focal length is how much? The focal length is given as 30 centimeter. and this separation is 40 centimeter. The 1 by V minus 1 by U. You don't have to worry about this 40 centimeter right now. You find out the value of V. After that, you have to think of whether the image is going to form beyond the mirror, or it is forming behind, it is forming ahead of mirror, so you don't have to calculate it. 1 by V minus 1 by U equals to 1 by F, and you can get the value. After the final calculations, the value of V that we have found out. The value of V that we have found out. Here, the value of U is still negative. Like here, 1 by V minus, it is negative actually, so minus minus becomes plus. So 1 by, this is 60, and which is 1 by 30. And if I calculate finally the value, how much we are getting? So 1 by 30 minus 1 by 60. So we have 60 as my LCM. So 2 minus 1, 2 minus 1 divided by 60. So it is actually 1 by how much we are getting? This is 2 minus 1. So this is 60 actually. Just a second. So we are going to get the value of V as our 60. The value of V that we are getting as 60. So if it is 60, so it is forming at a distance of here, say it is 60. So this is already given to us 40. If this is 60, from here we have a 20 centimeter ahead. From the mirror, it is going to be 20 centimeter. From the plane mirror, it would be a virtual 20 centimeter from the 20 centimeter from the plane mirror, and it would be a virtual image. So here we have, this is our answer. Because it is forming at 60 also, 1 by V minus 1 by E, if you get the formula and you find out the value of V, here we are getting the value of V as 60. So if it is 40 centimeter, it is forming here 60 centimeter distance. So it is already given as 40. So from that distance, it is going to be 20. So it is 20, and the image is going to be virtual. Come to question number 42. Here, 27 drops of the same size are now combining, charged at 220 volt. If they combine to form a bigger drop, they calculate the potential of the bigger drop. The potential is expressed as V equals to that formula KQ divided by R, and it is the potential for a single drop. And whenever we have 27 charged particles, we have how many? 27 charged particles. So the new charge is going to be 27 into Q, and the whenever they are combining, the radius is also going to be changing. And how the radius is going to be changing? The radius here is, it is going to be 3 times if you calculate, because the radius of one, that is 4/3 pi RQ, it is equals to 427 into 4/3 pi small RQ. So if you calculate the value of R is going to be here 3R, and if you calculate the value of R, and if you put the value of R as 3R and the value of Q dash as 27Q, you can get the value of total potential, which is now V dash, and which is KQ dash divided by R dash, and the value of R dash, if I put the value of 3R and the Q dash as 27Q, and then finally that we are getting as 9 into V. The value of V we have already found out, which is 220 volt KQ by R. So it is 9 into 220, and the value gives us as 1980 volt. So here we go with the option number 4 as our correct answer. Yes. Come to question number 43. Here also, in this questions particularly, I am going to give this answer in the Telegram, because finally this is the force. It will take some time actually. The question is not difficult, and the last moment I couldn't complete the calculations. Q into V cross B. The V is given as B I cap plus B J cap plus B0 K cap, because I had to discuss all the answers actually. So this is the value of B, and the value of V is also given. The Lorentz force, how it is expressed. If just you put the values of V over there, you put the value of B over there, and the force is given already to you, which is 4 I cap minus 20 J cap plus 12 K cap. So you do one thing, you take the cross product both sides. The value of V B you have this force equals to Q into V cross B. The value of V is known to us, and V is also known to us. The value of Q is also given as 1. You just compare both sides, you solve it, compare both sides, and then you have to find out this answer only. Okay, because the value of force is given, you have to compare what? Compare the coefficients. of I cap, J cap, and K cap? Yes, this question is little lengthy because whenever you are going to do this cross product, you have to take some time solving that determinant and all. It will take some time, definitely. I understand. It will take some time. It will take maybe 2 minutes to solve as well. Come to question number 44. It will not take some time. It will not take time. It is pretty easy questions. The inputs are given here, and the corresponding logic gates are also provided to you. So here we have 0, we have 0, we have 1. So you can think of, you don't think in terms of 5 volt and all. You think in terms of 0 and 1 in binary digits. It is going to be pretty easy to think of them. If it is 0, and so in B we have 0, so it is 0, it is 0 as well, because it is 0 here, and we have 1 in this C. So it is 0, 0 gives us 0 because of this AND gate, and 0, 1, it is 0, but it is an, NOT gate is also connected to that, so it is going to be your 1. So 0, 1 gives us 1 in the output. So here you can understand which of the option is going to be correct. So we are getting an output. So and here in these options, you don't have to go for other parameters. If you get this answer in first calculation, you don't have to think others. So it is 0, not correct, because in the output we are getting 1. It is not correct. In the option under 2 also, you can understand in the first input 0 to T1, in the timing of 0 to T1, it is also 0, not correct. In 3 also, it may be correct, but here you can understand it is given as straight. So maybe the possibility is not there. So in the number 4, as I can see, here we are getting an output as 1. Or else, if you want to think, if you want to go for more, you can definitely solve others. Like here, I think your Lcr is also waiting for discussing the chemistry. So if you want to think others also, like if I take this time period like T1 to T2, it is 1, it is 0. Here, if you have 1 in the input, it will take some time. It is not easy to think of in that examination also quickly. Understand? It is 1, and here in the input of B, we have 0, and we have again 1 here in the C. It is 0, 1, 0 gives us 0 again, and 1, 1 gives us 1, but it is going to be 0 then. And then it is going to be 0. Finally, we get 0. In the T1 to T2, we have 0. So T1 to T2, we have 0. This is not the right answer. This is the second one is also not the right answer. But you see, as 0, 0, and as we are getting here 0 in the output for the T1 and T2 range, but it is not 0. It is given 5. So this answer is going to be wrong. So option number 4 is somehow is going to be correct. So this is how we actually solve. So here I have a couple of questions still now. So I'm discussing it quickly. I have very less timing, and your chemistry discussion is going to be held right now. It's already 10 o'clock. I understand. Here it is simple. Just load into load arm into load into load arm. Load is 2 kg. Load arm, and here the effort into effort arm equals to load into load arm. If you do that, here as our calculations, you can see in our calculations that is 2 into 20, and it is here m into 160 minus 40. This is 120. If I do this, calculating just for 1 second, 120, it is going to be 20 multiplied by 2. If I do these calculations, the value of m that we are going to get as 1 by 3. Here option number 2 is the correct answer. And here in question number 46, here in the 46, it is pretty easy. We have done this question several times at our class also. Total number of loops. It will take some time. It's not that you will see the questions and do this in the instant. You have to calculate if you have not remembered the formulas and everything. Here, as in our calculations, number 46, we have found out the answer as root 3i into a square for the equilateral triangle, and for the square, it is 3 into a square. Option number 1 is correct. And it's pretty easy to calculate the magnetic moment whenever you calculate. This is m equals to, this is n into I into a. The number of turns, I into a. Number of turns, just you have to find out. A, this is the area, and area for the equilateral triangle, this is going to be root 3 by 4 into a square, and for square, it is a square. And the number of loops, I will find out. The length is given as 12a. Well, if I do the 12a divided by 3a for the equilateral triangle, it is giving us the value of 4. And whenever we calculate for the square, it is going to be 12a divided by 4a, which is given as the value of 3. So number of loops we have found out 4 and 3, and we can put the values in the n into I into a, and we can get the answer of magnetic moment as option number 1. Here in the question number 47, 46 is done. In 47, we have found out the option number 4 as a correct answer. You know the value of magnetic field is expressed as mu0 I1 divided by 2R1. Okay, and from there you can get the value of phi, which is B dot A. Okay, and by phi you can find out the value of mutual inductance, which is going to be phi divided by phi1, and you can get the answer as R2 square by R1 square as my correct answer. Come to question number 48. In 48, as per our conjecture, we have found out the answer as option number 1, which is the value of K as 3 by 4 that I can see here. So that was the total circular ring. Sorry. From there, 1/2 90 degree you have cut out, means this 1/2 you have cut out, right? So initially moment of inertia, if it is mr square, so finally it is going to be mr square divided by 4, and the remaining part, if I calculate, it is going to be 3 by 4 mr square. So the value of K is going to be 3 by 4 here. So the 49, it is given from the sun principle. It's pretty easy to calculate. It is not difficult. I hope if you have done complicatedly, I3 is going to be what? Current I1 multiplied by opposite resistance R2 divided by R2 plus R3. So here if I do I3 divided by, what you have to find out the ratio of I3 by I1. So that's all. I1 is going to be R2 divided by R2 plus R3. So here we have the option number 4 as our correct answer. And this question also, I have not got enough time to calculate. Finally, here you know the formula. Whenever we express the omega dash, it comes as omega r, the resonance, the frequency in the resonance plus minus the bandwidth, and it is given here 5 Henry, 80 microfarad, 40 ohm, 230 volt, and at which the power transfer to the circuit is half of the power. So delta omega is going to be your R divided by 2L. So the first frequency we have to calculate omega 1, which is going to be omega R plus delta omega, and the omega 2 that we have to calculate, which is going to be omega R minus delta omega. So from there you need to find out these two different frequency. You just have to find out the value of R by 2L. The value of R is given 40 ohm, L is given as 5 Henry, and the delta, this is the delta omega, and omega R resonant frequency, you know the value omega R comes as 1 by root over of LC. The resonant frequency, the value of L is given, C is given in microfarad, 80 into 10 to the power minus 6 you have to calculate. So with that we have almost completed all the options we have done almost. Only two questions. I think the last one, calculations, I have not completed, and another question was there in the section B also that I have not calculated. That we are going to give you the answer in the Telegram.
Okay. So sir, thank you so much. Here just one question. Question number 6. Ankita Ghoshal is saying that the answer is different for her. So if you kindly clarify the question number 6.
Achha, I'm checking that one.
Yeah, this one.
Achha.
Question number 6.
What answer?
The answer is different.
What answer he has given? She has given.
She hasn't written anything. And Ankita, feel free to write in the chat box. So I think we have discussed, this is our answer key. So just you revise one and just declare what will be our answer key.
Achha, yes. Okay. Achha, we'll definitely update this in the Telegram group. If I have any discrepancy, I'll just revise this thing once. And number 6, I'll definitely discuss this in the Telegram.
So I think we have concluded to this point, and we mentioned that 2 or 3 questions, as we have mentioned in biology, two questions in biology, 2 questions in physics. That something needs further verifications,
right,
and further research before declaring and confirming the answer, because this is to some extent what we feel may be controversial from teacher to teacher, and we making this solution. So basically we are starting our next session with our beloved chemistry teacher, Dr. Rashanjit Ghosh, and he will be continuing this session. So over to Dr. Rashanjit, sir, and I will request him to please turn on the camera. Yeah, and so okay. Yeah, all right.
Okay, so, all right, Rashanjit sir. So have a good night to all children.
Yeah.
and all the
Thank you, sir,
dear
for this nice
colleagues.
discussion, and we will be continuing the next session. Thank you so much for joining. So we are here, we can see Dr. Rashinjit sir, and we are just continuing this session. Sir, please share your screen, and yeah, so that we can start our session right now. Students are waiting. Yeah, so the screen is visible. Yeah, all right. And all right, the screen is visible. Sir, now you can start this session. Thank you so much, sir. So your voice, sir, please unmute yourself. Your voice is not audible. Yeah.
I'm audible?
Yeah, now
I'm
you are.
audible. Okay. So I think it's late night, so we will wrap up quickly. Before saying that, I think all of you have gone through the exam very well, because I don't know about biology and physics part, but chemistry part was mostly, I would say 70 to 80% was based on NCERT. So if you have gone through NCERT very well, I think you are going to crack at least a very good score in chemistry, first of all. Second thing is, the questions were very straightforward. Few of them were little bit tricky, but that is also, if you have a clear understanding of the concepts, then you will be able to do it. Okay, so don't get panicked. Whatever answer I am saying, it's a answer what we are giving. Okay, and second thing is, don't get panic if your answer is wrong. Okay, because what I always say is that there is nothing called genius. Everything is based on, and everything is on the result of your hard work. Okay, so let's start the session. Start with the first question. So in the first question, the question is, the noble gases are named because of their inertness. That's true. And inertness towards the reactivity, first of all. Acha, the incorrect statement you have to identify. Now the tricky part is here. This is a very straightforward thing. The thing is that it is given a gases. So basically they are gases. So that means that room temperature, they are gases. So what you have to identify, you have to identify the incorrect statement. Now, in the incorrect statement, it is very much evident that the incorrect statement will be the question of answer number 2, because they will have a lower boiling point. The gases which exist as the elements which exist as gases at room temperature, they will have a very low boiling point. That's very obvious. So that is why when I'm saying high melting point and boiling point, so obviously in one shot, that is a wrong answer. And rest of the things are correct. Noble gases have weak dispersion force, the London dispersion force. Noble gases have large positive values of electron gain in enthalpy due to the full field configurations, and they are spanningly soluble in the water, because we know that the KH value of argon is water is something, okay, which actually tells that it is less soluble, but it is sparingly soluble in water. Okay, now question number 52. The correct option for the body-centered unit cell in 14 type of Bravais lattice system. All of you know there are 7 lattice system, and depend on the different variation of the FCC, then the simple cubic and the BCC and the end-centered cubic, you have a different 14 types of total. Now in that type, there are 3 different types, that is called the cubic lattice, tetragonal lattice, and the orthonomic lattice. Only these 3 lattice contains your basically the body-centered cubic part. So the correct answer will be 3. So out of 14 types lattice type, you have 3 types is your Bravais lattice system. Okay. Now coming to the question number 53. This is a very simple. Cp minus Cv is equal to R, because this is the molar heat capacity at constant pressure, and heat capacity specific heat at constant pressure and specific heat at constant volume. And we know for the ideal gas, Cp minus Cv is equal to R. It's a very simple relation directly from the thermodynamics chapter. Acha, zirconium 54, the zirconium and hafnium. Zirconium is basically is a 5D element, and hafnium is a 6D element. Now between the zirconium is a 4D element, and hafnium is a 5D element. So the difference is in between, there is something called 4F comes in between. Okay, so what happens? They have a similar ionic radii, since the 4F orbital is incorporated between the 4D and the 5D. So it is basically, they have a similar atomic radius and ionic, because due to the lanthanide contractions. Right? Okay. Now, question number 55. It's very simple information-based questions from the blast furnace. from the chapter, your metallurgy chapter, the correct answer, the maximum temperature that can be achieved at the blast furnace, and that temperature is 220 Kelvin. And the 220 Kelvin, this is a molten slag formation, which actually happens at the bottom of the blast furnace. Okay, and that happens at 200, around 2200 Kelvin. Okay, 56. This is a very simple one. The acid strength increases in the order given HF, HCl, HBI, and HI. HBr and HI. Now, as you know that if you go down the group, from the halogen, the acidic character of the halo acids increases. Why? Because the size of the iodine increases. The size of the iodine increases, size of the element increases, and the iodine always try to prefer to stay at I-. So what it will do, it will readily release the H+ ion in the medium. And what happens? The acidic character increases. And this happens due to the lower bond dissociation energy. So the bond strength decreases. So yes, indeed, the answer is both statement 1 and statement 2 are correct. Both are correct. And if this is an assertion reason based question, then it is also a correct explanation also. Correct explanation also. Now, 57. The compound which shows the metabolism. It's a very simple. Why? In order to understand, in order to get a metabolism, you need that either a compound should be an amine compound or a compound should be an ether-based compound. Here you have to find it out that which compound forms the ether. Now you found out that this compound forms the ether. So what is this? If I look at here, that oxygen, so it can be a CH3 here and it can be a C2H5 here. Now, as a rule of metabolism, what I can do, I can take a CH2 part from here. I can incorporate it here. So it will be like this, C2H5, and here it will be CH3. So it is a metabolism. It shows the metabolism, right? So the correct answer is option number 2. Okay, now 58. This is the interesting one. For a reaction A to B, the enthalpy of the reaction is minus 4.2. So if it is minus 4.2, then what I can say? That formation of A to B, I can write H of B minus H of A is equal to minus 4.2. That is a negative quantity. That means H of B will be greater than H of A. That means enthalpy of B will be greater than enthalpy of A. Right? So the difference will be the negative. So basically what will happen? The B will be energetically higher compared to A. B will be energetically higher compared to A. And second thing is the enthalpy of activation is 9.6. That is this energy. The energy of activation is basically the product and reactant energy to the transition state. This is the 9.6. Right? So here, since from the clarification, it is lesser than the product energy of the I think something is wrong. Sorry. Okay. Yeah, it is negative. So, okay, sorry. Sorry. One mistake I have done. Very sorry. H of A will be greater than H of B. I'm sorry. I'm extremely sorry. H of A will be greater than B. That is, energy of the reactant will be higher than energy of the product. So, the answer will be option. Answer will be option 2. Right. Next one. The right option for the statement of the Tyndall effect is exhibited by which solution? First of all, a Tyndall effect is exhibited by a colloidal solution. So you have to find out that which of the solution forms the colloid. And the answer, all of you know, it's very simple. This is a salt solution. The glucose solution, no. Urea solution, no. The correct answer is a starch solution. A starch solution always form a colloidal solution you can make, and it will show definitely the Tyndall effect. Now, next question number 60. BF3 is a planar molecule and it's an electron deficient compound. Acha. Now, if I go through the normal rule of BF3, if I see, so BF3 is basically planar, means the boron has how many electrons? Electron 3, valence electron 3, and there are 3 fluorine, to total 6. So number of bonds is basically 6 by 2 is equal to 3. So it is a BF3 is a planar molecule. Now it's a planar molecule since it's a trigonal planar geometry. So definitely this is having the trigonal planar geometry. So the hybridization will be sp2. And from here what we can see the total number of valence electron is 6. So answer will be sp2 and 6. Next. 61. Another straightforward question, but little bit information here. PCl5, SF6, BRF5, and BF3. Now, PCl5, definitely phosphorus. If I calculate PCl5 phosphorus, the number of valence electron in the phosphorus is 5, chlorine is 5. So 5 plus 5, 10. So your number of bonds is 5, 10 by 2, 5. So forms 5 bonds. 5 bonds which forms the trigonal bipyramidal geometry. So A with 4. Next, SF6. So from here also you can do that. SF6 is sulfur, F6. So sulfur is 6, fluorine is 6. So total is 12. 12 by 2, total 6 bonds. So which structure forms the 6 bonds? Octahedral. So B with 3. Similarly, if I go to BF3, BF3 is my trigonal planar. Okay, and similarly, BRF5 has to be square pyramidal. So what will be the correct answer? The correct answer will be A4B2. A4B3 D, A4B3 D2 and C1. Option number 1. Next. The structure of beryllium chloride in solid state and vapor phase are. Now, beryllium chloride, this is a very important thing. Beryllium chloride is a diagonal element with aluminium. So if beryllium, like aluminium, beryllium also using diagonal relationship, beryllium also forms a dimer like aluminium. How? Like this. Like this. It forms a dimeric structure, right? So in a solid state, it is in a dimeric structure. And when you heat the system, it will go to the vapor phase. So the intermolecular separation will happen. So what will happen? It will go to the linear form. So the correct answer will be option C, dimer and the linear form. 63. The correct sequence of the bond enthalpy in the CX bond. First of all, you have to understand one thing here. CX means carbon. Carbon always makes halogen, a bond, sigma bond with halogen via the p orbitals, right? So here will be the carbon having 2p orbital and fluorine also have a 2p orbital. So CF bond will be very strong. Now, if you go down the group from fluorine to chlorine to bromine to iodine, the size of the atom increases and the orbital mismatch also tendency increases. So the bond becomes very weaker. Now, if the bond becomes weaker, then the energy required to break the bond will be very much low. The energy required to break the bond will be very much low. So which one will be the answer? Option number 2. So the CF bond will have higher bond energy to break, then the CCl, then the CBr, then the CI, right? Okay, and that is also reason why iodide is a very good leaving group. Let's say, how do you can understand this thing? Let's say this kind of alkyl halides, when it undergoes nucleophilic substitution reaction, if you calculate the rate of the reaction in all these cases, you will find for iodine, it is higher in rate. Because iodine is a better leaving group because carbon iodine bond is very weak. Now, which of the following polymers is prepared by addition polymerization? Now, addition polymerization is basically the polymerization which happens via the radical reactions. And definitely the answer will be Teflon. No doubt the answer will be Teflon. 65. The dihedral angle is least stable in the conformation of ethane. Now, this is very interesting thing. Ethane. You already know about the what is that called? Butane, the conformations of butane. The basic difference is basically instead of the methyl, you have a hydrogen here, right? So basically, if I look at 120 degree confusion, 120 degree here. So it will be like this. Sorry, if I look at the 180 degree, it will be like this. The least stable means definitely they will be in the eclipse form. Least stable means they will be in the eclipse form. That means they are like this. The three hydrogens of the ethane will be like this over to each other. So they will have a kind of a steric hindrance. So, and that state will be the least stable conformer. That is and the angle, dihedral angle between them will be 0 degree conformation. And similarly, this happens with the butane also, like that. And the most stable conformer will be the 181 because when they are totally anti to each other. Okay. Now, next question, 66. The organic compound contains 78% by weight carbon and the remaining is hydrogen. So how much is hydrogen? It is 22% hydrogen. Now, if you do the calculation here, you will find that in all these cases, the correct answer will be CH4. Because in this CH4, the carbon is your 12. Carbon is 12 and hydrogen is 4. Hydrogen is 4 and the total is 16. This will come approximately almost to a 75 to 76%. So from here also you can directly calculate without doing the calculation as you do in the basic concept of chemistry while calculating the molecular formula and the molecular formula and the what is that called, empirical formula. So you don't require, you just calculate the percentages of the carbon and hydrogen and check which is matching with the answer. It's very straightforward question here. Acha, 67. The molar conductance of NaCl, HCl and sodium acetate is 126.45, 426.16 and 91 Siemens centimeter square mole inverse, right? Now, here is the thing. This is something like a mathematics here. It's purely a mathematics here. How you can do this problem? First of all, what we know that we have to calculate the infinite dilution molar conductance for the acetic acid, right? So with what we can write here, I'm not writing the form, just I'm writing the CH3COO minus plus H plus, right? Now this one you can derive from this sodium acetate and this H plus you can derive from the hydrochloric acid, hydrochloric acid. So let's say if I do in this way, suppose my NaCl is basically Na plus Cl minus, HCl is H plus Cl minus, and CH3COO Na is basically CH3COO minus plus Na plus, right? Now what you can do, now let's say this is my equation number 1, this is equation number 2, and this is equation number 3. Now if I do in this way, 3 plus 2 minus 1, then what will happen? So in this case, your Na plus from here and Na plus from here will be cancelled out because here is a minus, and your chloride and chloride ion will be cancelled out. So what you will get? You will get only H plus and acetate minus. Now this equation I will put in their values. How I will write that? So 3 is for 91. So it will be 91 plus 426.16 minus 126.45. And if you do this calculation, you will get value 390.71 Siemens centimeter square mole inverse. Siemens centimeter square mole inverse. Right? Okay. Now, next one, 68. Statement 1, aspirin and paracetamol belong to the class of narcotic analgesics. Aspirin and paracetamol, definitely they're analgesics, no doubt in that. Morphine and heroin are known as the non-narcotic analgesics. Morphine and narcotic, they are also analgesics, but morphine and heroin, all of us, we know this is a very famous two analgesics. So basically they are narcotic, and aspirin and paracetamol is commercially available. So definitely they are non-narcotic. So it's a very simple, you don't need to know the chemistry also to answer this question. Okay, so the correct answer will be both statement 1 and statement 2 are false statement, right? Next one. This question is little bit tricky, but it is also straightforward kind of. How? It is given, there are 3 solutions are given, P1, P2, P3. P1 is for glucose, P2 is for urea, and P3 is for the sucrose. Okay. Now the fundamental idea is that here you have to calculate the osmotic pressure. Now how you can calculate the osmotic pressure? We know pi is equal to CRT, right? That is, the osmotic pressure is proportional to the concentration. Let's say here I am representing the concentration by the molarity. I'm representing, right? So what we know from the definition, in the molarity is basically your mass by molecular weight divided by volume in liter. That is mass by molecular weight into volume. That is, the concentration is inversely proportional to the molecular weight, right? And which is directly, and that is also inversely proportional to the osmotic pressure. Now you have just, what you have to do, you don't have to see the what amount is given or how much water is given, because all cases are same. But what you have to calculate here, you have to calculate is which one is having the lowest molecular weight. So the lowest molecular weight will have highest osmotic pressure. The lowest molecular weight will have highest osmotic pressure. So which one is having the lowest molecular weight here? The urea, that is 60 gram per mole. Then it is glucose, and then it is sucrose. So the correct answer will be P2 will be greater than, P2 will be greater than P1 will be greater than P3. So lower the molecular weight, higher the osmotic pressure. Simple, straightforward. Acha. Among the following alkaline earth metal halides, which one is covalent and soluble in organic solvent? This is a question from a Fajan's rule. That is, your group 2 metal halides, when you go down the group, the ionic character increases, right? And if you go above the group, the covalent character increases. And the correct answer will be beryllium chloride. Beryllium chloride is having covalent character, and this is due to the Fajan's rule. And what Fajan's rule says is that explains the covalent character of the ionic compound, and the final idea about the Fajan's rule is that no inorganic or compounds are purely covalent or purely ionic. Okay, and which we can prove also by valence bond theory and as well as a molecular orbital theory. Next. Identify the compound that will react with Hinsberg reagent which will dissolve in alkali. Now, this is one interesting one. Now, Hinsberg reagent, if you know that from the chapter amines, the Hinsberg reagent is those reagents which are used to identify the primary, secondary, and the tertiary amines. So first, you can directly remove this option. Second, which one will give you a solve which will dissolve in alkali? First of all, what is Hinsberg reagent? This is Hinsberg reagent, right? Now here, the thing is that if a primary reacts with Hinsberg reagent, then what will happen? It will form this molecule. The lone pair of nitrogen will attack the sulfur, the chlorine will leave, and it will form NH. Let's say this is the R group. If a secondary amine reacts with this molecule, what will happen? It will form NR2, like this. Now, if you see between this primary and the secondary and tertiary amine will definitely not react, because there is no, the hydrogen cannot be removed here. Now, if you can see here, the primary and the secondary amines in between, there is a hydrogen here in the primary amine, by which, if you give an alkali in the medium, by which can produce an anion, and it will make a salt, and definitely it is going to be solubilized in the alkali. So the correct answer will be the primary amine. So this is a secondary amine, this is a primary amine, and this is a tertiary amine. So primary amine will be soluble in alkali, secondary amine will be not soluble in alkali, and tertiary so definitely will not going to react. That is why using Hinsberg reagent, you can distinguish between primary, secondary, and tertiary amines. Next question. The number of tetrahedral and octahedral voids in a hexagonal primitive unit cell is, it's a very simple hexagonal unit cell. So it will have a six octahedral voids, and since it is hexagon, that is 6 into 2, because we know tetrahedral void is number is 2. So 6 into 2, 12. So answer will be 6 and 2. 73. The correct structure of 2,6-dimethyl dec 4-ene-3 is. Now, all you can see the mother chain here is basically dec, 10 carbons. So there is no confusion here. Now the point is here that what you have to figure it out that what will be the numbering here. Now you have to think that the number, in case of the number in your group, should get a minimum preference. The side chain will get a minimum preference. So which one I will opt for? I will opt for all cases, but here let's see if I do the numbering from here. 1, 2, 3, 4, 5, like this, 6. Okay, 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, 7, like, and 1, 2, 3, 4, 5, 6, right? Now here you can see 2,6-dimethyl. Now in which case you have in both 2 and 6 position you have dimethyl in compound number 1 and compound number 3. But in 4th position you have the double bond. But in compound number 1 you have in 4th position the double bond. But in compound number 3, in the 3 position you have the double bond. So the correct answer will be option number A. That is 2,4-dimethyl dec 4-ene. Next, 74. RBC is a deficiency of disease of, it is a disease of anemia. So, and it is very simple. I don't have to tell the biology students to do that because it is a vitamin B12. It is a vitamin B12. Okay. Right. Next. Which of the following methods can be used to prepare a highly pure metal which is liquid at room temperature? Now, let me tell you all one thing. When you're talking about a liquid pure metal which is at liquid room temperature, which metal is liquid at room temperature? All of we know mercury is a liquid at room temperature. But definitely by electrolysis and zone refining, you cannot refine a mercury. You cannot refine a mercury because mercury stays as mercury halide as an ore. And this one is first what is done. This is a part of a pyrometallurgy part. And what it is first oxidized to the air. Then it is separated by a process which is known as the distillation process. So this is a question from the pyrometallurgy part. Okay. Now, next one. Question number 76. What is the IUPAC name of the organic compound which is formed in the following chemical reaction? You can see definitely the question is a Grignard reagent and it is dry ether. So it will definitely a Grignard reagent reaction, right? So let me write the reaction first here. So what will happen? Let's say you have an acetone molecule here and you have this molecule, C2H5Br. So what will happen? C2, CC, CH2, CH3, CH2Br. So what will happen? This part will attack here. So what it will form? This one, right? Now you can see the compound is, the mother compound is a butane, right? Butane. And 1, 2, 3, 4. So at 2 position you have OH also, 2 position you have methyl also. So the correct answer will be 2-methyl-butan 2-ol. 2-methyl-butan 2-ol. Okay, right. Next one. Achha. This question is this HBr. First of all, you see HBr. Now, when I'm saying HBr addition to the double bond, there are 2 types of addition. One, in the presence of a peroxide, that will give you the Markovnikov product, and the absence of absence of peroxide, that will give you the Markovnikov product, and the presence of peroxide, that will give you the anti-Markovnikov product. Right? Now you can see here it is given a peroxide. It is given. This is a benzoyl peroxide. It is given, and this peroxide, what will happen in presence of peroxide? You will have an anti-Markovnikov addition. Anti-Markovnikov addition. That is, the primary carbon will be attached by the halogen atom, and the carbon which is most the secondary carbon atom, or the most stable carbon center will be attached by the hydrogen. So the correct answer will be option number 1. You can see the less substituted one, sorry, the primary carbon here, it is attached by the halogen atom, which is one of the part of the anti-Markovnikov addition to the double bond. Right? Next one. The incorrect statement among the following is contraction is greater for the element than lanthanide contraction, number 1. Number 2, yes. Number 2, most of the trivalent lanthanide ions are colorless in the solution. Yes, this is a correct statement. Trivalent lanthanide ions are the colorless in the solid state. Acha. And actinide contraction is also greater than a lanthanide contraction. Okay. Now, lanthanides are the good conductor of electricity and heat. Now, there is a point here. What happens in the case of lanthanoids? Although you can say that, sir, they are the metals, they will conduct the heat and electricity. But let me tell you, lanthanoids, they are basically classified as the inner transition metals. They possess softness, more softness compared to the D metals, right? And although they conduct the heat and electricity, but they have a very high resistivity. So they are not a good conductor of a heat and electricity, right? So definitely this is a false statement. So the incorrect statement is option number 3. Right. The particular station of All India Radio, New Delhi, broadcaster frequency. See, this question was given in the way to confuse you because there are a lot of informations are there. But let me tell you, it's a very straightforward question, and it is basically based on a simple wave mechanics. Simple wave, right? So what is given? The frequency is given. That is the nu is given. That is 1368 kilohertz. That is 10 to the power 3 hertz. So I can write second inverse because 1 has second inverse. And the wavelength, you have to calculate the wavelength, right? And the speed of light is given 3 into 8, 10 to the power 8 meter per second. So how you can calculate wavelength? Wavelength is equal to frequency is equal to c by lambda. So wavelength is equal to my c by nu. So if you do this calculation, you will get exactly 219.3. You will get 219.29 and it will give you 219.3. So don't confuse with rest of the options. 219.3, 219.3 meter, right? 219.3 meter. Next, question number 80. Which of the following reaction is the metal displacement reaction? Right. This was the question. It's a very simple one. Metal displacement, you have to find out the metals. Okay. In the reaction, you have to find out the metals. Now you can see in the first reaction, the KClO3 is decomposes into KCl and oxygen. It is a decomposition reaction. It is not a displacement reaction. So definitely this is not. Option number 2, CrO2O3Al will give you Al2O3 and Cr. So here the chromium is getting reduced and the aluminium is getting oxidized, and as a whole, and as I say here, the metal is also getting displaced. So definitely this is one is going to be the metal displacement reaction. Okay, metal displacement reaction. Next, 81. Choose the correct option from the graph. Okay, now Boyle's law. Definitely Boyle's law is given. So you can easily omit 2 and 3 because 2 is pressure volume. Does not work in that way because pressure, we know from the Boyle's law, pressure is inversely proportional to the volume. And what we know, PV is equal to constant. And if you do the ideal equation, it will be PV is equal to nRT, which is a constant term in case of Boyle's law. So what Boyle's law said, at constant temperature for a fixed mass of a gas, the pressure is inversely proportional to the volume. So definitely the pressure volume graph will going to give you the rectangular hyperbola. So that is between the option number 1 and option number 4. Now I will choose which one. First of all, you have to think that in case of option number 1, if you go above, the temperature decreases. And if you see option number 4, go down above the temperature increases. Now, in all these cases, what you have to find out, let's say if I take a point at this PV graph. Let me draw it here. Let's say if I take a point at PV graph here. So this point will, whatever it will give you, it will represent the area of this graph. And if you increase the graph, next graph, so it will again increase the area. So basically it is decreasing the pressure into volume. Sorry, it is increasing the pressure into volume. That means it is increasing the nRT. That means it is increasing the temperature. So basically, if you increase the temperature, the graph is going to be higher. So, and each cases for higher temperature, the area under the curve between the pressure and volume will increase. So which option I will choose? I will choose option number D. Option number D. Okay. It's a very simple one, a little bit conceptual, because you need to know the pressure into volume gives you the area, and that area is basically nothing but gives you the another value of a temperature. Depends on the value of the temperature. Right. Next. 82. Okay. 82 is basically, you can see here, dimethylamine and acetic acid. Now, both are a weak acid and a weak base. So definitely when they form a salt, the salt will be consisting of a weak acid and a weak base. So in order to calculate the pH of the salt, which is consist of weak acid and weak base, we have to use a direct formula. And what is that formula? pH is equal to 7 plus half of pKa minus pKb. Correct? So if I drop the value, 7 plus half pKa of acetic acid is 4.77 minus pKb is 3.27. So if you do the calculation, you will get the answer 7.75. You will get the answer 7.75. Right? So this is a very simple one, Just you have to directly calculate. You have to remember the formula of the salt formed by the weak acid and the weak base. Clear, everyone? Okay. Next question. The major product formed by the dehydrohalogenation of a reaction of 2-bromopentane is pentoene. Let's draw the structure of 2-bromopentane. Chalo, let's do that. 1, 2, 3, 4, 5. So it's a 2-bromopentane, right? Now what it can do? If it undergoes dehydrohalogenation directly, either it can form this compound or it can form this compound, right? It can form this compound. Now, which one it will form? Definitely it will going to form this one, because the more it forms a more substituted alkene, and that is the direct consequence given by the Sedgwick rule. And this is known as the Sedgwick product. This is known as the Sedgwick product, and this is known as the Hoffman product. And it is stable. Why? Because it is more substituted. Because it is more substituted, and more substituted alkenes are more stable due to the hyperconjugation that all of you know. It's a very simple thing. It's a very simple thing, right? So the correct answer will be the Sedgwick rule. Ethylene diamine tetraacetate is, first of all, EDTA. It's a complexing reagent, right? Complexing reagent, and definitely what it is a ligand. It is a ligand. Now it is EDTA, ethylene diamine tetraacetate. So when I'm saying tetraacetate, so there are 4 oxygens are already there. And ethylene diamine, that is diamine I'm saying, so that means 2 nitrogens are already there. So 4 plus 2, 6. So there are 6 donating centers are there. And that is why EDTA is one of the best hexadentate ligand. It's known as the hexadentate ligand, and the correct answer will be option number A. Correct answer will be option number A. And it is a hexadentate ligand with 4 oxygen and 2 nitrogen donor centers, right? And all of you know it's a very information question, and it's very simple. Okay, and EDTA is a very good complexing agent, and you can, this actually used in inorganic analysis, where you can complex any metals, literally any inorganic metals, by using the EDT. It's a complexing reagent. Right. Next, 85. Tritium is a radioactive isotope that emits which of the following particles? Okay, first of all, what is tritium? Tritium is one of the isotope of hydrogen, that is H31. H31, right? Now 3 is this mass number and 1 is the atomic number. Now definitely your mass number is 3, so it will definitely not going to emit alpha, because what we know, what is alpha? Alpha is basically helium atom, which has 4-2. So 4 is not there, so definitely it is not going to emit alpha, not there. Why not gamma? Because the nucleus of tritium is not that much heavy like uranium or plutonium or radium, so that it will emit gamma. So gamma is not new. No. And neutron, I don't think so anyone emits a neutron. So the correct answer will be option number 1, beta particle. Because basically, what is a beta particle? It's basically one of the electron. So beta, when it emits a beta particle, it's basically 1 electron is getting added. So it will be H3. So the correct answer will be the beta particle. So that was the questions, all of your 35 questions from the group A section, which was mostly informative based and the understanding based questions. And it's very nice, very beautiful. Okay, now coming to the section B. So here you have to attempt 10 questions out of the 15, but I will here discuss all the 15 questions, and let's see how much you have done. Okay, next one. Makes the list. This one, you have to do a little bit calculation. But most importantly, what you have to think in your mind here, 2 things. What is the oxidation state of iron? This you have to think first. And second thing, what kind of ligands are they? Now, if you can see here, the iron Cn minus is a strong field ligand. Cn minus is a strong field ligand. So when a strong field ligand binds with a metal, it forms a low spin complex. It forms a low spin complex like this. And when a weak field ligand like water, it is a weak field ligand. When it binds to a ligand, it will form a high spin complex with a low gap. You have to do a little bit calculation. And here, if you can see, in FeCN6 3 minus and FeH2O6 3 plus, in these 2 cases, iron is in +3 oxidation state. And in these 2 cases, iron is in +2 oxidation state. Now the question is, what is which one? Right? Now here, you have to do a little bit calculation here. You have to do the electronic configuration. Now Fe3 plus is a D5 system. And your Fe2 plus is basically your D6 system. Now what will happen if you do the calculation for the D? Let's say I'm going to the D5 system first. So what I will take? Iron high spin and iron low spin, let's say. So this is my cyanide complex. This is the low spin complex. And I will take a high spin complex of the water. High spin complex of the water. Now if I go to the D5 high spin. So sorry, D5 strong, D5 low spin. That is for the cyanide. So it will be 1, 2, 3, 4, 5. So number of unpaired electron is 1. So what is the magnetic moment in this case? Root over of 1 into 1 plus 1. Sorry, 1 into 1 plus 2. That is root 3. That is 1.73. So definitely your option A is coming with 4. Option A is coming with 4. Now what about second one? 3 plus. So iron 3 plus, it is a high spin complex because water is a weak field ligand. So if I do that, high spin means 1, 2, 3, 4, 5. It can go to the EG level definitely. So number of electron pair is 5. Your unpaired electron is 5. So it is 5 into 5 plus 2. So it will be coming around root over of 5 into 7. So it will coming around root 35. So it is approximately 5.9. So your B with 1. A with 4, B with 1. Right? Okay. Achha. Next one. So A4, B1. Definitely you can already identify which option. You don't have to do the rest. So it's option number 4. Right? Next one. Which of the following arrangement in the given sequence is not strictly according to the properties indicated against it? Okay. HCl, HF, you have to go a little bit slowly here. Why? Because the trends are here. So since the trends are here, so basically you have to look at the characteristics of the group element which are mentioned here. Okay. First three are the hydrides and second last one is the oxides. Okay. Here, this one, they are basically the halides, halo acids, and definitely if you go down the group, the acidic strength increases. Why it is increases? Because the hydrogen and iodine, as I discussed in the few questions back, that hydrogen iodine, they will have a iodine size is larger, so the hydrogen iodine bond strength is very weak, so it can be easily dissociated, right? So it dissociated means it will produce more number of hydrogen ions in the medium, and as well as what will happen, the acidic character increases. So definitely this is a true statement. True statement. Next one, H2O, H2S, H2SE, H2T. It is the increasing value of pK. First of all, pK value depends on the acidic character, right? Now, but higher the acidic character, lower the pK. Why? Because we know pKa is basically minus of K value. Minus of K value. So if you have a lower value of K, if it is a highly acidic, then the pK value will be low. pK value will be low if it is highly acidic. And if you go down the group for H2O to H2SE to H2C, using the similar reason, the bond strength, weaken of the bond strength between the hydrogen and the corresponding elements, it will have higher acidic character. So higher acidic character will be lower pK value. So definitely this part is contradicting with each other. So it is showing the increasing pK value. So if you go down the groups, it will show the lower pK value. But it is showing here stating here the increasing the pK value. So definitely this is our incorrect statement. This is our incorrect statement. Achha. Just little bit for your information, I can tell you this one, that increasing the acidic character for this one. Yes, indeed, because ammonia is the most basic. And if you go down the group, the basic character decreases. So as a whole, the acidic character increases. Acidic character increases. And the 4 white is not, because if you go down the groups, carbon, silicon, tin, lead, what happens here? The tendency of getting from +4 state to the +2 state increases. Why? Due to the inert pair effect of the lead and tin. Due to the inert pair effect, the tendency of forming the +2 oxidation state from the +4 oxidation state increases. So basically, if lead is going from +4 to +2, definitely it is accepting the electron, and that electron has to be given by someone. And who will give that? Who will give that? The person, the species which is oxidized. That is why if you go down the group, the oxidizing character increases. So these two are basically the true statement, and this one is a false statement. Right. Next one. The correct option, the 4 gram of oxygen and 2 gram of hydrogen confined in the total volume of 1 liter. It's a simple PV is equal to nRT questions. Now, point is here you have to calculate the total number of moles. Total number of moles of 4 gram of oxygen and 2 gram of hydrogen that you have to do. How you can do that? How you can do that? So 4 gram of oxygen will have 4 by 32 moles, right? And your 2 gram of hydrogen will have your 2 by 2, that is 1 moles, right? So this is my 1 by 8. So total my number of moles is 1 plus 1 by 8, that is 9 by 8 moles. Right? So what you can do now, you have to calculate the pressure. So PV is equal to nRT. So we know volume is my 1 liter. Volume is my 1 liter. N is my 9 by 8. R is already given 0.082. 082. And your temperature is given 273 Kelvin. Now, if you put those values, right. If you put those values, you will get the answer 25.18. You will get the value 25.98 atmosphere. 25.98 atmosphere. It's a simple PV is equal to nRT based question. Very simple. Right. Now, this one. Next, question number 89. Which of the following molecules is a non-polar in nature? Right. POCl3. Now, in order to understand which one is polar and non-polar, you need to know their structures. Now, POCl3, what is the structure? Right? POCl3 is a tetrahedral structure. Phosphorus. So definitely this will have a very good dipole moment because there are heteroatoms in one direction and two heteroatoms in different direction. So definitely in this case, the dipole moment there, it will be a mu will be not equal to 0. So it will be a polar molecule. CH2O. This is a formaldehyde, and you know definitely formaldehyde is a very good polar molecule. For formaldehyde, mu is also not equal to 0. It's definitely a polar molecule. Now coming to SbCl5 and NO2. SbCl5 and NO2. Now NO2, I will come to first NO2. You will say, sir, NO2 the planar. NO2 is the planar. Sir, NO2 is planar. Then NO2 will definitely have a non-polar group. Why? But no, because nitrogen here has a lone pair of electrons, which actually develops the polarity in NO2. So definitely NO2 is not a non-polar molecule. It's definitely a polar molecule. It's definitely a polar molecule. And this why polarity comes? This polarity comes due to the lone pair present over the nitrogen. The lone pair present over the nitrogen. Right? And SbCl5, what is the structure of SbCl5? Let's look at. So SB. So all the direction you have a homoatoms are here. So this is a trigonal planar state. Trigonal planar state. So in this trigonal planar state, what you have? In the case of the trigonal planar state, your dipole moment is equal to 0. We always know this one. And this one in the bipyramidal structure, mu is going this direction and this mu is going this direction. So in this case, the overall resultant dipole moment is 0. So dipole moment is 0 means the molecule is a non-polar molecule. So SbCl5 is definitely is a non-polar molecule. Achha. Now this question, I have a little bit confusion also in this question number 90. If I use a normal knowledge between sodium borohydride, comparison between sodium borohydride and lithium aluminum hydride, sodium borohydride is a weak reducing agent compared to lithium aluminum hydride. So this I will later on will clarify further and I will let you know in the Telegram group. But as far as if you ask me immediately the answer of this question, so I will say it will the answer will be option number 4. Because if maybe I'm wrong, but I'm not sure this thing that the sodium borohydride cannot reduce a ester molecule. It's a ester molecule is here and there is a ketone molecule. Ketone part is here. So it can reduce a ketone to alcohol. Fine, sodium borohydride. But it will not reduce the ester part. So this one I will further clarify and I will let you know in the Telegram group. But as far as if you ask me now, I will go with option number 4. Because you can see here the ester group is not affected, but the keto group is affected and it is reduced to the OH group. Okay, fine. Next one. The slope of Arrhenius plot ln(k) versus 1/T for the first order reaction is minus 5 into 10 to the power 3 Kelvin. Okay. Now, what is Arrhenius equation? All of you know, definitely. So, if I do this one, K is equal to A into e to the power minus EA by RT, right? This is my Arrhenius equation. Now, let's take ln in both sides. Ln K, ln A minus EA by RT, right? Now, what they have shown, the plot versus ln K versus 1/T. And if you do the plot of ln K versus 1/T, you will get this kind of graph. That is the intercept of ln A with a negative slope. Intercept of the ln A with a negative slope. And this negative slope is what? Nothing but your EA by RT, EA by R negative slope, and which is equal to given minus 5 into 10 to the power 3. 10 to the power 3. And if you do the calculation, EA is equal to then minus will cancel out. is R, that is the 8.314 multiplied by 5 into 10 to the power 3. If you do this calculation, you will get the value 41.5 kilojoule per mole. 41.5 kilojoule per mole. You will give the answer 41.5 kilojoule per mole. Okay. Next one. 92. Match the list 1 with list 2. Okay. This is a name reaction based, your name reaction based question. Acha, first one, benzene with carbon monoxide, HCl, anhydrous, a Lewis acid. So this reaction is known as the Gattermann-Koch reaction of preparation of aldehyde. Gattermann-Koch reaction of preparation of aldehyde. So A2. Next, this one, RCOCH3. Definitely this molecule contains a ketomethyl group, and you will have a NOx, sodium halide, sodium epoxy halide you have. So this reaction is known as the haloform reaction. This ketomethyl group will be formed, this methyl group will form the haloform, and this part will be oxidized to your acid. Next one, see, this is an alcohol is there and an acid is there, and you have a concentrated acid group, mineral acid. So this reaction is known as the esterification reaction. So A2B3, and definitely this is X2 red phosphorus. There will be a alpha substitution in this reaction, and this is known as the HBZ reaction, Hell-Volhard-Zaleski reaction. So the correct answer will be A2B3 C4D1. So which one will be the answer? A2B3 C4B1. Right. Next one. For isothermal reversible irreversible expansion of an ideal gas under isothermal condition, irreversible expansion of an ideal gas under isothermal condition, the correct option will be. Now, when I'm saying isothermal condition, definitely my U should be 0. It does not matter it is reversible or irreversible. Your answer, in this case, your U should be 0. Why? Because the internal energy always depends on the temperature. Next, the irreversible expansion, and what we know, for a reversible process, your delta S is equal to 0. But for your irreversible process, your delta S will be greater than 0, that is not equal to 0. So which one will be the correct answer? For isothermal condition, if I use, my delta U should be 0. And if I use the irreversible expansion condition, my delta S will be not equal to 0. So the correct answer will be option number 3. Option number 3. Because this is the condition for isothermal reaction, isothermal process, and delta S for irreversible, this is basically one of the statement which is formed from the second law of thermodynamics. Next question. Intermediate form in the X in the following chemical reaction. This is also very simple question. This is called chromyl chloride in a non-polar solvent. The tendency of the chromyl chloride is always, if you see their mechanism, chromyl chloride always have a tendency to form a chromyl ester first. Then upon hydrolysis, it will give you the corresponding benzoic acid. It is one of the oxidation of the toluene using chromyl chloride in non-polar solvent. So the correct answer, this one is the chromate ester. So the correct answer will be option number 1. It forms the chromate ester. This is an intermediate chromate ester. Chromate ester. Intermediate chromate ester. Right? Next one. Match list 1 with list 2. Okay. This is a question from your environmental chemistry, and this is basically all the reactions which you observe in different kind of pollutions. Okay, now which one is what? First of all, if you don't know also, you can say that this is basically the depletion of the calcium carbonate in presence of sulfuric acid. And why it happens, we know that Taj Mahal, the glaze of the Taj Mahal is reducing every day. Why? Due to the acid rain. So definitely C will go with option number 1. Right? Next, go to option number B. So C1. Which answer is C1? You can see this one. Let's correct another one. Option number B. If you can see, the option number B is basically they are forming a radical. And when they are forming a radical, definitely it is going to the, this is going to the ozone layer, and that will go to the, okay, that will go to the ozone layer depletion. So B will be option 3. This one, NO plus O, this is basically what? This is basically my photochemical smog. You can see in presence of a photon, it is forming a smog. NO plus oxygen, it is known as a photochemical smog, which we discussed in our class several times. Okay. And this one, the sulfur plus oxygen in presence of sulfur dioxide, this is known as a tropospheric pollution. So the correct answer will be option number 3. Option number 3. Okay. So we are in the last phase, only 4 questions are left. The molar conductivity of the 0.007 molar acetic acid is 20 Siemens centimeter square mole inverse, right? So you have to calculate the dissociation constant. Now, this is very simple, very, very simple. What you have to do? First, you have to calculate the molar conductivity of the acetic acid in infinite dilution, and the data are given. So what is this lambda 0 of acetic acid? Acetic acid, that is 350 plus 50. That is 350 plus 50. That is 400. And how you calculate the degree of dissociation? Alpha is equal to the lambda, which is given, divided by lambda 0 of the infinite lambda c by lambda 0. So what I will write here, 20 by 400. So that is your 1 by 20. 1 by 20 is my alpha. Now, you have to calculate the dissociation constant of an acid. How you can do that? Just you go to visit to the chapter chemical equilibrium. Ionic equilibrium. You go to that. So what I can do that? CH3, COOH, we can write it as CH3, COO minus plus H plus, right? Initially, it is C, it is 0, 0. This C is already given, that is 0.007. Finally, let's say alpha is your degree of dissociation. So C is C minus C alpha, C alpha, C alpha. So what is the dissociation constant? Ka, C alpha into C alpha divided by C into 1 minus alpha. And what we can do, we can use this concept by the Oswald dilution law. We can use C alpha squared, right? C alpha squared. Now what you can do, your alpha is given already here. That is 1 by 20. And your C is already given here. So it is 0.007 multiplied by 1 by 20 square. And if you do this calculation, you will get 1.75 into 10 to the power minus 5. If you do this calculation, you will get 1.75 into 10 to the power minus 5. That is option number 3. That is option number. It was little bit calculation, but it is simple. It was very simple. Concept was very simple. Very simple. Nothing complicated. It is there. Acha. 97. From the following pairs of the ion, which one is not an isoelectronic pair? Now, how you can calculate isoelectronic pair? You just calculate the number of electrons. That's it. Okay. Now you can see oxygen and fluorine. Definitely F minus is neon and oxygen is also neon. So they both have 10 electrons. They are isoelectronic pair. Next, sodium plus and magnesium 2 plus. They also have a 10 electrons of neon. So they will also 10, right? M2 plus, Mn2 plus and Fe3 plus. Interestingly, these two systems are D5 systems. These two systems are a D5 system. Let's say iron. Iron atomic number is 26. 26, right? 26. Now 3 plus. You remove 3 electrons. So it is 23. So 18 minus 23, that is 5. So they contains 5 D5 system. Similarly, Mn2 plus. Your manganese is also 25. Minus 2, that is 23. Minus 18, that is also 5. That is also 5. So basically, so in Mn2 plus and Fe3 plus are D5 systems. So definitely they are isoelectronic species. And similarly, what you can see here, Fe2 plus is a D6 system. Fe2 plus is a D6 system. It will have 1 electron excess. So these two are not the isoelectronic pair. So option number 4. Okay. 98. Coming to the question number 98. Okay. The reagent R in the given reaction is, first of all, in this reaction, NH2 and you are giving NaN2 dilute HCl. So definitely it is going to form a diazonium chloride, right? Now you have to think of a reagent which forms hydrogen, which replaces the diazonium chloride by a hydrogen. You have to think in that. Now, first of all, I can readily omit this one. Why? Because this is the example formula Sandmeyer reaction, where you COC and HCN, you put cyanide there. This also I can easily remove. This will give you iodine. Now water will give you OH. So what I can give? The correct answer will be CH3, CH2, OH. Alcohol. Ethanol is going to give a hydrogen here in this particular carbon center in the place of diazonium salt. There are two reagents actually. One is a ethanol and second is a phosphoric acid. You have to remember this one. Okay. Achha. Both of these reagents replaces the diazonium salt by a hydrogen. Okay. 99. The correct option for the value of the vapor pressure of the solution at 45 degrees Celsius is benzene to octane is 3:2. So what will be the total pressure you have to calculate? This is a direct application from the Raoult's law. Direct application from the Raoult's law. How you can do that? Okay, here your P0 for benzene, it is given 280. And your P0 for the octane, it is given 420, right? Acha. Now, what is the mole? You have to calculate the number of moles. Molar ratio is 3:2. So, what is the mole fraction of benzene? 3/5. 3/3 plus 2, that is 5. And mole fraction of octane is 2/5. 2/3 plus 5. Now, if you do the calculation, P total, if I use the Raoult's law, P total is 280 into 3/5 plus 420 into 2/5. 2/5. And if you do this calculation, you will get the answer. You will get the answer 336 millimeter. 336 millimeter of Hg. 336 millimeter of Hg. It's a direct, simple value putting calculation using Raoult's law. Simple problem. Next one. Last question. So, and the last question of the paper discussion also. CH3, CH2, COO minus, Na plus, sodium hydroxide, and what will be this reagent? First of all, you can see here that there is in between the product and the reactant, there is one difference. Difference is that there is a difference in the carbon CO2. So you have to find a reagent which actually does a decarboxylation reaction in basic medium. And basic medium is already given. Now, which of the following? This red phosphorus is not your decarboxylating agent. Diol H is a reducing agent. Red phosphorus is also your red phosphorus, B2H6, they are all a reducing agent. So which one is a decarboxylating agent here? Option number 3, calcium oxide. And you can see it is indeed, it is there in the your NCERT book. And this reaction, all of you know, those who have studied, all of you know, this reaction is known from the coal-based electrolysis reaction. This is from the coal-based electrolysis reaction. That's it. So I think from here, what I can say is that the chemistry question was extremely good part. Okay, although there was one question was little bit confusion from my side, but that will also clarify in the Telegram group. And what I think that if you have given exam in a calm mind and a prepared mind, I think you can score a very, very good marks, at least in the chemistry part. That I'm sure. Okay, because most of the questions was straightforward and I can say 70 to 80% questions was NCERT based. Okay, so fundamental idea is that you have to go through the NCERT line by line. And those who are going to give next year, one suggestion I can give you all, that you have to make sure at the end of the year that you have literally ate the NCERT book. Literally ate the NCERT book for all the 3 subjects, physics, chemistry, and biology. Okay, so that's it. Thank you, everyone. Thank you, PrepMed team. Okay, and good night to all of you. I will take a call from here. Okay, thank you everyone. Tanmay sir. Okay.